that numerical problem. It was regarding the transmission line. It was stated that it was a lossless transmission line. So we have defined certain parameters, right? So can somebody tell me what are the parameters?
Sir, load impedance.
Yeah, 1 second. Yeah, this is I am talking about IA1. Okay. If anyone wants to note down, please note down. Okay. Load impedance was how much?
500
That
ohms.
was 500 ohms, right?
Yes,
and,
sir.
Some people have mistook this one as for R. They have not understood what is load resistance, what is load impedance. Load resistance, load impedance, both are same, but they have taken it as R and they have got confused with impedance. They are not even equated. Now here, another term was L. L was how much?
9 micro Henry per meter.
Very good.
9 microhenry per meter.
Microhenry per meter. So this will amount to your how much? 9 into 10 to the power of minus 6 Henry per meter. Right?
Meter.
Correct, no? So now we had another terminology, that is C, which was 100 picofarad per meter. Now here, so many things have happened here. Some students have, I don't know whether they have gone through the paper or not properly, or I don't know what they have written. So they have done mistakes here. They have written this picofarad as a microfarad. See, this mistake you can't do in exam. See, because you are electronics engineer, electronics and communication engineer, we cannot afford to do such mistakes. If you are unable to note down what is picofarad, what is microfarad, it is very bad actually. Now we are in higher semesters also. So you are expected to know all these small terminologies. So for a picofarad, it is people have written 100 into 10 to the power of minus 6. So it is wrong actually. So we have to write 100 into 10 to the power of
minus 12.
Minus 12 farad per meter. So this is the value. Please correct yourself. If you are not aware, please, I don't want you guys to do same mistake in exam. VTU exam, if you do, you will get 0 marks for this. I'm telling you, because there are certain professors who will not accept this kind of mistakes. So you have to be very, very careful. So with that, when we know that we have to do such kind of problems, we have to be very, very careful in understanding especially the units. For an engineer, if you can't recognize the units, then we are failed. We are not engineers. Then we are what? We are all that people who are administration job, who are managers, or maybe a kind of people who are not knowing any engineering subjects. So with this, what we have to calculate. So our given data is this. So we have to calculate what? First of all, we have to calculate Z0, the characteristics impedance. Then what we have to calculate? We have to calculate
frequency
coefficient. Then we have to calculate
frequency.
Then we have to calculate SWR, that is standing wave ratio. So this we have all 4 parameters we have to calculate. So I had given 1 marks for this, 2 marks for this, 2 marks for this, and 2 marks for this. So simple. So I have mentioned only 3 because for calculation of these 3 we have to anyway calculate RZ. So that's why I have not mentioned. So it was in the back side of them. So what is the formula for Z0?
Root of L by C.
L by C, because we had
lossless.
Some people have done the derivation. I don't know. They have done the derivation, and they have done this derivation means in this problem they have written fantastic. It's good actually. But problem is they should understand. I had mentioned that lossless. So lossless means, see, okay, fine. I'll just concept. I'll clear it so that it is very easy for you to understand. So what is exactly the Z0 formula? Actual formula? R plus
J omega L.
J omega L
divided by G plus J omega C.
G plus J omega C. Correct? No. So when we know this, some people have written this also, and they know that it's a lossless line. So R will be is equal to 0, and what will be 0? G is equal to 0. So this will lead to your, yeah. Anyone?
Square root of L by
Square
C.
root
by
of
C.
plus j omega L by square root of j omega C. So this will lead to your square root of, sorry, so 0, 0, so it will be j omega L by j omega C, so which will be your j omega cancel, so you will remain with L by square root of L by C. So that's why we have some people, some students have done this derivation. They have done, but they have not calculated. I don't know why. They know the concept, they know the formula, they know everything. Even beyond the things they know, but they have not calculated. I don't know why. This is very sad to see such characteristics of students. Anyway, so for ZL, so for we have to calculate Z naught. So Z naught is given by, as per the formula what we have. So it is square root of L by C. So now here square root of L is your how much? 9 into 10 to the power of minus 6 by your 100 into 10 to the power of
10
minus
power of minus
12.
12.
Simple calculation. So if you calculate this, everyone will get some value. What would be value that
300
one?
ohms.
300.
9 into 10 to the power of 4. Correct, no?
Yes, sir.
Or it will be 300.
Ohms.
Correct, no? No.
Yes, sir.
Correct, sir.
So we have Z naught 300. So reflection coefficient is given by, we know what is the formula for reflection coefficient? ZL minus Z naught by
ZL minus Z naught by ZL plus Z naught.
Z0 plus Z naught. Very good. So with this, what happens? How much is this thing? This is your 500 minus 300 divided by 500 plus 300. So this will give you how much? 200 by 800. So this will be your 0.25. Okay. So this will be 0.25. So your what is the frequency? Frequency is given by
1 by 2 pi into root LC.
very good. 1 by 2 pi root by LC. So if you substitute the values, so 2 pi into square root of the total 9 into 10 to the power of minus 6 into 100 into 10 to the power of minus 12. So if you calculate this thing, it will come to approximately 5.3 megahertz. Correct? No, everyone got this.
Yes, sir.
So then last point was, okay, I will use here. Don't worry. Okay. Last point was what? VS, that is SWR. So SWR is given by what formula?
1 plus reflection coefficient.
1 plus?
Reflection coefficient. Divided by 1 minus reflection coefficient.
Correct, no? Everyone correct?
Yes,
Yes,
sir.
sir.
1 minus or 1 plus, sir? Numerator?
Plus, sir.
Plus
1
no?
plus.
Plus denominator minus, sir. Correct, sir. What you have written is correct, sir.
1 plus or 1 minus, sir? I am doubtful.
It's correct, sir.
Correct,
What
no?
you written is correct, sir.
Okay. Fine. So what will be the answer here? 1 plus 0.25 by 1 minus 0.25. So this will be 1.25 by 0.75. What is the answer? What is the answer? Around 1.66?
Yes, sir.
Correct, no? So 1.666 something it will come. So this is how the problem. Now here some students, they have mistook this question. I don't know what they have done. Here they have put the picofarad, they have put microfarad. They have changed themselves. I don't know why. They have not seen the question paper properly, or I don't know. They have changed and they have done correctly. All rest all calculation is correct, but there is some issue with this picofarad. So then one student has done this one. They have put the formula. They have given everything. They have put the formula, but they have not done the calculation. That means they have put up to this point. They have done, but they have not done the simplification. This is also one problem. So I don't know why they have done like this. Okay. Okay. This is one issue which I wanted to discuss. Another issue was there was another issue that reflex klystron. I want to clarify here. Some students, only some few students have done correct Applegate diagram. 90, 80, 70 to 80% of the students, those who have attempted reflex klystron, they have done Applegate diagram wrong. So if you write such thing, because we are all electronic engineers, the moment the professor examiner will see the paper, he will just put 0 because you have not understood the concept. See, we all know, I have told 100 times in the class when I was taking the reflex klystron. See, we have done that reflex klystron, right? So I just once again I'll repeat for the benefit of the students who have done wrong. See, I will just draw the reflex klystron in the simple way. This is your electron gun, a small electron gun. What we have, then we have a tube. Then we tube. Okay, I'll put in my figure. I have to make it very prominent. Okay, I'll use it here. See, this is your gun, electron gun, and then we have a tube. Then we have a repeller. See, this is our tube, and then we have the anode cavity. This is one cavity, both sides actually interconnected in between. So please don't misunderstand. This is one. People will think that it is all one, two cavities. Why we call one? It's only one cavity only. Backside it is there. It is interconnected inside. Okay. So now we have the electrons. We have to connect some this thing. No. So some people have not connected this anode with any circuit at all. I don't know why. Can we afford to do that? So this is your repeller, and this is, we have to connect some power supply here, right? This is another power supply here. So people have done wrong here. See, this is the simple circuit which is there. People have connected supply here. Are we supposed to connect the supply here? Everyone, 80% of the students who have attempted reflex klystron, they have just mugged from some notes. In spite of giving I have given clear notes. I have given neat notes. So please don't use any power supply here. We are not supposed to use power supply. People have used power supply here, mentioning here minus positive, right? They have mentioned here minus positive. Correct. But what about here? Here it is a plus minus, right? Now what will happen? I'm just if I connect like this, is it okay? Is this circuit okay?
No, sir.
No. So that's why the power supply should not be here. It should be, I told you in the other circuit, people, I don't know, somewhere the mistake has done. They have repeated all mistakes. One college has done the mistake. In the notes, they have done every mistake. See, this is the negative and positive here. So now here, see the positive, here positive, negative. Here also positive, negative. So now you can see the same terminal here also, the positive voltage is there. Everywhere positive is there, positive here. So here also positive. Now we cannot have negative here. If I have negative, then I cannot have negative and positive terminal joined together. It will be short circuit. So this is absolutely wrong concept. People, please correct yourself. In the exam, please don't repeat this. Please put the power supply here. Don't put the power supply here. It is wrong. Most of the students have done that. Though I have not cut the marks, I wanted to uprise because I have given full marks, but this is wrong actually. Okay, and all anode cavity is positive. Some students have written anode cavity as negative. This is positive. This is also positive. This electron gun is negative. So all those mistakes. This repeller is also your negative terminal, negative potential. Both are at negative. So that's why the electrons move out from here. Electrons are negatively charged particles. That's why they get repelled from here, the repulsive force. Why? Because same negative is there. I don't know how people can do such mistake. Please understand, this is very, very important. Don't repeat such things. Otherwise, we are all matured engineers. If we do such things, then it's very bad actually. Because if you are not understanding here, what happens is somehow you will clear the exam. Don't worry. But what happens is the moment you go to some corporate, wherever the reflex, because you will have to deal with reflex klystrons so many places. Not only in defense, in other corporate sectors, in so many microwave systems, wherever you go, you will deal with. There, if you do such mistake, then you will be fired at one immediately because you are not having any idea on this. So that is how because you will be doing this mistake, then there also you will do same mistake and you will actually damage the reflex klystron. So no one will give you a job for this. So please understand, your concept should be very, very clear. Okay, is it clear? Anyone has got any doubt, please clarify now only. Because once I want that all of you, once you are pass out from here, your idea should be very, very clear, and you should not do such silly mistakes in exam or wherever in the world, wherever you go. Is it clear? Anyone, any doubts?
It is clear, sir.
No doubt, sir.
Okay. So shall I take it out now? Now coming to Applegate diagram. So this is very important. Another mistake. So okay, Applegate diagram. I have told that it is very simple Applegate diagram. Nothing much in that. I don't know. People just mugged from some. I don't know. They are copying from other notes. I don't know where they are getting these notes. They're all wrong written notes. They are copying. They are mugging it and they are coming and reproducing whatever they have written. So it's very bad if you are not understanding at least whatever notes I have given, you study that. So it is all authenticated and I have rechecked, I clarified so many times so that you will not do the mistakes. In spite of some clear instructions, students are just getting notes from somewhere and they're getting, I think maybe some seniors are helping, I don't know what is going on. So they're all giving the wrong notes and they're reproducing things, not understanding the concepts. Now here, please understand this Applegate diagram. If you do not understand Applegate diagram, you will get 0 marks in exam. Please understand Applegate diagram. So we have done this. Again, I am repeating for the students who have done the mistakes in the exam. So we have a sinusoidal wave. We have a sine wave which is moving in this direction. Now bunching is happening. Now we should understand this. I already explained, but still I am repeating once again. Now there is one electron which is at this point it is starting. I will consider, and this is the one electron I consider this is reference electron which is a reference electron, and electron which is at the negative peak, which is a late electron I consider. See, all electrons if I consider early electron. So if I just take this, so this will be your early electron. Sorry, E early, this is reference, so early E I take, this is E. So E early, so this is your, please understand here clearly, once again I'm explaining for the benefit of the students who have done the mistake in the exam. If you do same mistakes, you will get 0 marks. Now all these three electrons I need to bunch. Some students, they have bunched, though they have done the Applegate diagram, but what they have done, they have just mugged, or I don't know whether mugged or just they have glanced and just they reproduced. They have not understood the concept. It shows clearly that you are not understood the concept, just you have written whatever it is there. See, what happens is the bunching happens only at the positive peaks. We all know it. Only at the positive peaks, but some students have bunched all these here somewhere in the negative peak also. That means they are just blindly they took and they are drawn like this, like this. They have bunched here. Is it okay to bunch in a place where you are bunching somewhere in the negative region? This is absolutely wrong. That means the bunching has not taken place. It is retardation. It has taken place. See, please understand that thing. So whenever you are drawing anything as an engineer, you have to be very, very careful in small things. Otherwise, what happens now in the future when you go and do such mistakes in the companies or corporate world or in the Air Force or somewhere, then people will think that you have not understood the engineering concepts clearly, that your professional knowledge is 0. People will think professional zone, they will just grade you and they will stamp you as a bad engineer. Once you are stamped as a bad engineer means lifelong you cannot change it. You will have to remain with that stamping. Bad engineer, he is professionally very weak, people will tell. Technical skills are very weak. So this is how the things are outside, please. So my bunching will only happen at this position, positive peaks only. Positive, everyone knows what is positive peak. I need not to reiterate. So please use this technique. Here first bunching will happen here. All the electrons will early reference and all electrons will bunch together at this place. And there is another bunching happens at this place also. That's this positive peak also. So this happens here also. So This is another bunch. Again, third will also happen, which I cannot show you here because of the constraint. So now this is one bunching happened at the positive peak. Please understand. And second bunching is happened at the second positive peak. Again, third will happen at the third peak. See, never the bunching process will happen at the negative. Why? Now, people should ask question. Why, sir? Why can't we have negative? Why can't the bunching will happen at negative? Those people who have written at the negative, no. So please answer why. Why can't we have a negative? You only prove, you only written no. So kindly tell me. You want me to tell your names and ask question? I have written down names, those who have attempted. Okay, I will not take the names, but see, why we have to do it on the positive? Because there is a reason for that. See, bunching means RF amplification. But power is getting accumulated. More and more power is getting accumulated. I am taking out RF output from here. From these bunches, I am taking out RF outputs. RF output means output power I am taking. If I take output only, I will take at the positive so that I'll get the full gain output. If I take at the negative, my output will be negative. So I'll not get any amplification. I'll get retardation. So there will be negative power. So please understand that. Okay, is it clear? Any doubt in this? Anyone? Please tell me now. If you have, please clarify yourself. Otherwise, I don't want you guys to repeat the same mistake in exam. I appreciate that some of the students have attempted that question. I fully appreciate. Very good. You have written nicely. You have explained very nicely. You have written all things. But these are the small mistakes which I have not cut the marks. Okay. For everyone, I have given full marks. Though you have done the mistake, but I wanted to correct here so that same thing you don't do in the VTU exams. Because all those professors who are coming, they are not our, they know only they see the paper. They will just see, okay, this guy has not understood the concept. Immediately they may reduce the marks. Most of the time they reduce because your concepts are not very clear. They may give you half marks maybe. Out of 10, then only 5 marks will be given if you do such mistakes. So why to lose out marks on that for small things? So that is how these two observations in my question. Otherwise, rest all questions people have attempted very well. Even antenna part also people have done very well. Derivations and except for few students, those students I don't know what is the psychology of those students. They have done only, some students have just done 1 question, 2 question. Just they have written something. I don't know why. Whether they are not interested. If at all you are not interested, then should not attempt any such question because you will lose out marks. I given one person 14 marks out of 30. I don't know what to do because I wanted to give him marks, but he has not written anything. If you're not attempting anything, it is very difficult for us to give marks. So that is the problem. So kindly attempt at least. If you don't, at least write something. Okay, anyway, fine. So we'll start with one more important chapter today. That is, so all are with me? Everyone understood? Is there any doubt till now?
No, sir.
No doubt, sir.
No doubt? Are you sure? No, Saurabh, Mahima, all are you good students. They are good, but others, I am talking about others. Some of them I have written very well actually. For them, I have given 30 out of 30. Those who are written good, I have given them 30 out of 30. I am like that only. I will give. If you are written, I will give full marks. No cutting of marks, except for if you do any silly mistakes. Yes, mine some marks I have cut, but otherwise most of them I have got good marks. Please, I will give you one sample paper how to write answers for what kind of questions answer how to write. And what all needs to be covered. So that is very important. Some people have just, there is no head, tail, just they have written some answer. Actually, they will lose out marks in the final exam. You have to score more. See, you have to attempt, your attempt should be to score 100 out of 100, not just only 70, 80 marks. If you try to score 100 out of 100, then only will land up scoring somewhere around 70 to 80. So that should be the attitude. You have to do best in the exam. You have to present best. There are some papers I am really very nice to see those papers. Exceptionally written, very well, well organized, well written, well neat diagrams. One is example of Saurabh Bhatt paper, excellently written. Good, Saurabh, very good. So we one person, and he has not done any mistake on the Applegate diagram also. So there is another student also, I don't remember, one girl student also. She has also written very good, excellent. So I want that everyone should write good, not only few students. I want everyone to write good. That is what my aim. So that everyone can score maximum marks. I want that everyone should score 100 out of 100. So that is my vision. I don't know whether I'm going to achieve it or not, because I have seen the attitude of the students. Some students, you will just see the paper. If you see the paper, then only you will say. By seeing the paper only, you will come to know what is the attitude of the student. So that is very bad actually. We should not do that. We have to at least be serious and do some effort. Should put some efforts and write correctly. So this is a small thing which is expected from you guys. And you don't take it as a this thing. I don't want to give lecture, because whenever I talk to my daughter also, she also starts, don't tell me all that nonsense and all. So she is in 3rd semester in PES. So that's why. So anyway, so now I'll not go much on this. So I'll concentrate on the other thing. So okay, please, we'll come to this. I will add one more new topic. Today we'll discuss on symmetrical network. This question has come in VTU exam, so we'll just see what is this. Okay. Can you see the board?
Yes, sir.
Yeah.
So we talk about the symmetrical network. Can anyone tell what is symmetrical network? We have discussed little bit in the initial classes. Kindly bear with my handwriting, not very good. Okay, this symmetrical network. Everyone, we know we have done some in the last class. What we did reciprocal network. So what was our important point which we concluded in the end? Anyone? Impedance related to impedance Z parameters.
Sir,
Z12 was equal to
Z21.
huh?
Z12 was equal to Z21.
Yeah, Z12 was equivalent to Z21, right? That is the reciprocal. Now for symmetrical network, simple to remember is we have to prove that Z11 is equal to Z22. Understood? That means what I want to say is your okay, I will write the sentence, you note down. Everyone please note down this. A two-port network. There's some network issue here. Wait, I'll just do this so that you can freely. It's getting disconnected something. So if I switch on video, it will be smooth. Okay, a two-port network. Please, everyone, write down. This question will come. Define a symmetrical network and prove Z1 something like that they will ask. A network is said to be a symmetrical network if the ratio of voltage to the current at one port is same as the ratio or a ratio of the I will take this, pull it down, ratio of the, where this dot has gone. Sometimes now we miss out this dot. Yeah. Ratio of the voltage to the current at the other port with one of the port is open circuited. Is it clear? A two-port network is said to be a symmetrical network if the ratio of the voltage to current at one port is same as the ratio of the voltage to the current at the other port. That means at one port we have voltage and current, at other port also we have voltage and current. So their ratio should be same. So what does it mean? So if I draw a network, so how it will look like? So I have a two-port network. So we have one is your we have current, we have other side also we have current here. So we have this is your I1 current entering, and we have I2 entering the port 2, and we have the voltage also here. So V1 is the voltage here. So and we have a voltage here V2. Now this is a two-port network. Now, as per the definition, what I should write? What should be my equation? Can anyone tell me? This is port 1, right? This is port 1 and this is your port 2. So at port 1, if I take a ratio of voltage to current, what is that?
V1 by I1.
I1. This is V1 by I1, ratio of the voltage to current at port 1. And what is the ratio of the current here? Voltage and current here in the port 2?
V2 by
V2 by I2. That means, as per the definition goes, I should have V1 by I1 when open circuit is also there, no? So I say I2 is open circuited, that is I2 is 0, should be equal to your V2 by I2 when the other port 1 is open circuited. So here, in case of V1 by I1, when port 2 is short circuited, that is I can write here. Here, port 2 is open circuited. Okay. And here port 1 is open circuited. So if I have this condition, then I will get this equation. So how will you get? So simple. We have done the equations. How we have done the equations? We all know. Can you tell me the master equations? What are the master equations? Can anyone tell me? Simple.
Is equal to Z11 I1.
V1 is equal to Z11 I1 plus Z12 into I2 V2 is equal to Z21 into I1 plus Z22 I2. So with the same equation, now if I make like for port 1 open circuit, sorry, port 2 first we'll take, port 2 open circuit, and then what will be this thing? So what I get, we know V1 is equal to, if I make a port 2, I2 will be 0. So we get Z11 into I1 plus Z12 into 0. So that is open circuit we are doing. So when we do this, we get only Z11 I1. So therefore, we know that V1 by I1 is your, what is the value? Z11. Correct? No? Everyone clear?
Yes, sir.
Yes, sir.
Similarly, if I take the other this thing, other port, that is, I'll just draw a line here. Port 2, port 1 open circuit, if I do, then what happens? What will be my equation? So this will be, similarly, I can write V2 by I2 is equal to what? Z22. So these two, now we can see both as per my definition, V1 by I1 should be equal to V2 by I2 where for symmetry. So therefore, I can say that my network is a symmetrical network. Z22 is equal to Z1. So this is the proof. So tomorrow question may come, prove that your this thing is symmetrical, network is symmetrical. Then you need to prove to show that this is the Z11 is equal to. See, sometimes what happens, you may be given with a network, you may be given with a kind of a small resistive network showing that so many resistances and all, show that whether the network, check that, confirm whether it is a symmetrical or reciprocal, something like that. So what you have to do is you have to take the matrix and do the transpose and see if Z11 parameter is equal to Z22, then it is called as a symmetrical network. If Z12 is equal to Z22, then it is called as a reciprocal network. So now I'll give one small example here to understand you better. See, these things you need to understand, these all ports and all, very important. I'm highlighting this. This is very important. And also this, okay, now I'll give one example here. Okay, I will go to next page. Okay, please everyone concentrate here. Now you have to tell me, okay? Now you understood the concept. I'll put a Z parameter network, 2-port network. Okay, I have written values like say 1 by 4, 1 by 4, 1 by 4, 0. Whether this Z parameter network is reciprocal or symmetrical?
Reciprocal.
Reciprocal, very good. This is a reciprocal network. Who is this? Rainak? Who was this?
Yes, sir.
Rainak, very good, Rainak. Okay, now everyone is with me. Why it is reciprocal?
Sir, because Z12 equals Z21.
Z2.
Yeah, these two are same. Z12 is equal to, that means Z12 is equal to, sorry. Your because Z12 is equal to Z21. That's why I can write it as here Z12 is equal to Z21, which is equal to 1 by 4. So now in the same network, if I make it, see, please understand this clearly, very clearly. I'm telling you all. See, if I change this parameter, okay, now I'll put one more this thing. Now tell me. 2 by 3, 1 by 3, 5 by 3, 1. Whether it is a reciprocal or what? Mahima?
Sir, it's neither reciprocal nor symmetrical.
Very good, very good. It's neither reciprocal nor it is a symmetrical network. So if I make it like say, if I make it here 2 by 3. Now,
So now it's symmetrical, sir.
now it is symmetrical. Why it is symmetrical? Anyone who can tell me why it is symmetrical? Because see,
Is
we
that one
terms are
equals to
same.
Z?
See, that means why I am giving this hint is very easy to understand. If these two terms are same, then it is symmetrical. So I can call it these two as same symmetrical. If the other two are there, then I can call it as the reciprocal. If these two are same, then reciprocal. So that is very important. That means to make this as reciprocal or any kind of these things, so we have to be very sure that we have this kind of setup, understand the setup. So what I make it as a 5 by 3, then what happens? This is now tell me what is this?
Symmetrical as well as reciprocal.
Yeah, it is both. It is reciprocal also, it is symmetrical also. So please understand. If you get any matrix like this, they will ask you to show whether this thing, so easily you can show. This is your, what is this? This is reciprocal network, and this is your symmetrical. So kindly understand this, very important. I'll put using the yellow. I'll put other color. So this is your symmetrical. This is your reciprocal, right? So anyone, any doubt in this? Any student can answer question, can clarify the doubts. It's very, no one will speak actually. Problem is that this is reciprocal, this is symmetrical. Is it clear?
Yes, sir.
Yes,
Okay.
sir.
Then we have one problem to solve. Let us solve one problem. This is a small problem. I may expect this time. I'm thinking that this may come in exam. Okay, I will give you. You must have already done this in your maybe. So here it is. We find the z parameters. Question may come. Find the z parameters. Find the z parameters for the circuit. Now we have a circuit like this. You must have already done this, sir. So maybe just refreshing. This time I am expecting this question. Everyone, please try to do this. We have here where this dot has gone. Very, very difficult to find out this dot. 2 ohms, and this is 2 ohms, and this is 3 ohms. Then we have 1 ohm. Then this is 1 ohm. So with this network, we have to find the Z parameters for the circuit. Can you be able to do? You must have done in the previous sessions in your classes, maybe 3rd semester or 5th semester. This is current I1. I'll give hint. You can try at home. Don't worry. I'll give hint so that you can just try it out. This is port number 2. So I'll write 2 and 2 dash. So and we have 1 and 1 dash, port 1 dash. So basically what happens is this is port 1 and port 2. So we are here, we have a current I1 flowing like this, and we have a current I2 flowing like this. Then we have I3 flowing like this. So we have all 3 currents like this. So apply your KVL in first mesh This is your first mesh, right? First mesh, second mesh, and third mesh. See, if you apply KVL to first mesh, you will get some equation. Like say you will get V1 is equal to, you will get I1 into 2 ohms plus you will get here because the current is in the this thing I1 minus I3. We all know this basics, 1 ohms. Correct? No? Is there any doubt in this? So this
No,
is
sir.
some
No, sir.
equation like this. V1 is equal to 3I1 minus you will get I3 like this. One equation you get like this. So one equation for first mesh. Now you'll similarly you find out second mesh also. Like it will be if you apply KVL to second mesh, you'll get something 2 ohms into I3 plus 1 ohms into your I1. What is that? I3 plus I2. Both the currents are in the same direction. Plus 1 ohm into your what will be that? I3 minus I1. Something like that. You will get all these things. So when you apply this and simplify, when you simplify, you will get some equations. Okay, just try it at home. So why I'm telling you, it's not a homework, but just a equation which you will get some equation in the form of like you may get I3 is equal to 1 by 4 times of I1 minus I2 like this. If you simplify, you'll get one more equation, equation number 2. Similarly, if you apply KVL, this is for KFC. This is the KVL for that small dot is missing again. It goes with the mouse. I'll change the size of the, then only it will be easy. Yeah, now we can easily. So similarly, you will have one more equation. Like it will be. What I mean to say is this is for KVL. KVL for first mesh, and this is KVL for second mesh. And then when you apply KVL for third mesh, you get another equation, that is V2 is equal to, you'll get 4 times I2 plus I3. So this equation you get a third equation like this. So when we have all these 3 equations, then you get like if you compare, you put value of I3, like you have I3 this value. So you know this, or you can put some other value also, whatever value you put in one value and get the values of equations. Like in the form of like we calculate all these things, we just put it in the standard form. What we have for equations in this form, right? V1 is equal to some equation, but it is in I1 and I3. Here I1 and I2. So I want these V1 and V2 in the standard form. That is what we have, Z parameter standard equations we have now. You put all these equations, try to simplify and to get it done. Like V is equal to Z11 into I1 plus Z12 into I2. Like that, we have another equation the same, no? Z12, Z21 into I1 plus Z22 into I2. So you have to get these equations in this form. When you get these equations, so all your whatever parameters you are there, so these are your Z parameters. You have to obtain in this form and get this thing. So nothing is there great in this. You have to simplify this. You have to put one of the values. You have to put the value of I3 in equation 3 and I3 value in equation 1. If you put that, you will get the same values in V1 and V2 form. So I will get I1 and I2 in the terms of I1 and I2. Basically, you have to get here now I3 you have to convert into I2 because we don't have I3 here. That is the main thing. Understood, everyone?
Yes, sir.
If you're unable to solve, I will solve it in the next class. Or should I solve now?
No, sir. We'll try and then
Try it out if it is not getting, because I want you guys to try a little bit. Otherwise, you will not be able to never understand the problem. Okay. Okay. So I want to give you one homework. Please take, this is an official homework and it will be posted on your this thing also. So it is from the question paper. So please note down. Can you see the question paper?
Yes, sir.
Okay, please copy question number 3A. That is a question, homework question assignment is show that or prove that impedance and admittance matrices are symmetrical for a reciprocal junction. 6 marks question. So I'll be giving it for 10 marks or 20 marks. Yeah, I will give it for 20 marks. So assignment will be for 20 marks. So one more question is there. So this is for 10 marks and another question for 20 marks. Please everyone note down. Show that or prove that impedance and admittance matrices are symmetrical for a reciprocal junction. Actually, it's a very small answer, but anyway, you try it out. Everyone note it down. With the matrix only, you will be able to identify whether it is symmetrical or reciprocal. So that should be the your expertise. Everyone note it down. Shall I take it out? Show that impedance and admittance matrices are symmetrical for a reciprocal junction. Saurav, over?
Yes, sir.
Yes, sir.
Okay. So I want to show you some papers. There is another question which is there. This also you try it out. If you can find out, do some research. See, we can every time if I tell everything, then everything will get evaporated within minutes. So if you do research, it will remain. So I want this also. You should try. 3A, for a 2-port microwave network with mismatched load. For a 2-port network with mismatched load, derive an expression for an input reflection coefficient. 6 marks. See, this is a tricky question. For a 2-port network with mismatched load, derive an expression for input coefficient, reflection coefficient. See, he is telling that it is a mismatched load. That means whenever load is mismatched means there is a reflection. Definitely there will be reflection. Now, what is that reflection coefficient? So we all know that we measure reflection coefficient in terms of whatever amount of the energy is getting reflected back. That is measured in the reflection coefficient. So we have to measure that. Is it clear? And there have been certain other questions like this, but I don't want that. Only 2 you try to solve. Okay, and this is another question is there, but I don't want to solve. Just I'm going to show you. What is a reciprocal device? Network device, this thing will remain same. And write 5-point comparison among S parameter, Z parameter, Y parameters. We have done Z and Y. So S parameters when we do is just a comparison. We know that Z and Y are inverse. And we also see that what are the S parameters in the next class. So sometimes a question may come like Z parameter is given like this. Now what is this network? Mahima, I'm asking you, what is this reciprocal or symmetrical? This network?
So neither reciprocal nor symmetrical.
No, yes, both. It's not there. Okay, right. Very good. Very good. So, any doubts till now? All understood clearly?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, na? So I want others to also respond. Prajwal, Tanupriya, Beena. Have you understood, Beena?
Yes, sir.
Is it clear everything?
Yes, sir.
Okay, good. Some people have written very good actually. Even Beena also written very nice. And there is another girl, I don't remember. They also written very good actually. Some of the papers, it's a demo papers. Even Rainak Sharma also written very good. Actually, I have got so many people seen answer papers very good actually. Those people who are not attending classes also, they have written very good. But only thing is small mistakes they have done regarding that Applegate diagram and the presentation of answers is also very important. What happens is, see, understand the psychology of the examiner who is correcting the papers. He is busy in correcting the papers one by one, one by one, one by one. He is correcting all papers. See, what happens is the moment he sees any bad paper, bad means your handwriting is bad, you are not presented nicely, you have not written the equations properly, you have done the so many corrections. What happens is if he sees that, he will, it will be, psychology is that this student is not having any idea. The student is not good in the studies, something like that impression he will. Once he has that impression, he will always, he tries to give you less marks in every question. So that impression shouldn't have. So always you should present your answers very neat and clear, very nicely, nice handwriting. Try to maintain a neat and clear handwriting, and present yourself with some borders, something, some extra efforts if you put, and highlight certain things, underline certain things. I have seen no one has done this highlight or underlining. At least you can do that, highlight or underline. So if you do that, you will attract for more marks and presentation. Don't worry, I'll give you one paper, how to write an answers for what kind of, like numerical, how to write, for a normal construction and working, how to write, everything I'll tell you. Okay, so that why I'm telling you is, okay, I'll take another 2 minutes from you, 2 to 3 minutes, then we'll wind up. See, I was writing VTU exams. There is a PhD exams. I was, in fact, I am a student, some time back I was PhD scholar. So I got my doctorate degree. Before that, we have to write some coursework exams. We have the 4 subjects we have to write before actually we get comprehensive Viva and all. So for that, I went to one college for writing exam. There's so many engineering colleges, they will give any engineering college, we have to go and write. So I was in one of the room, I was sitting, and I was waiting for the question paper. The one out of 4 subjects, all 3 went on well. Very nicely I have written all. But one subject, like I was sitting, and the question paper was very, very tough. And I saw students, after getting question paper, within 5 to 10 minutes, they started moving out from the hall. So 90% of the students, they moved out of the hall. So even I thought of moving out because it was very, very tough. I was 100% sure that if I write also, I will fail. So that was the question paper toughness. But you know what? I decided. I said I'll attempt. I'll give it a try. What I did, I thought I will whatever I know, I'll present it in a good way, and I'll try to put whatever best possible. I was the only student who was sitting and writing the exam. Believe me, in the hall, everyone left. That 1 more 2 3 people were there. They left after half an hour. But 3 hours I was sitting there. I did everything. Though I was knowing only 30% of the question paper. But what I did, I made it. I nicely presented whatever I know, and some whatever other extra I had that I also I put. But whatever best possible, within 3 hours I attempted, and I was the only person to clear in VTU exam. I was the only person to pass that exam in that category. So that's what I could have failed, but I tried my best to write neatly. I have written diagrams very neatly, handwriting very neatly, the equations neat, one by step, explaining each step I have explained neatly. So if I do that, even examiner will also feel, no, this student has put in efforts, so let us pass. So I passed. Though I passed in the C grade, other I got the A plus and all I got, but this was only I got a C plus, something like that. So, but I passed it. So many people, students, other scholars have failed. So I'm just giving an example. Okay. Anyway, fine. Thank you so much for your patience hearing. I will take an attendance. I'll pick up the attendance. Wait for some time. I am saving the attendance. Okay, this is the system generated attendance, so there is no ambiguity. Okay, thank you so much. We'll be marking your attendance as per the whatever. Okay, all the best. Do well.
Thank you, sir.
Thank you, sir.
Saurabh, please stay back. Saurabh, are you there?
Yes, sir. Yes, sir. I'm here.
Yeah, okay. Saurabh, what could be the deadline for the assignment?
So the deadline for the assignment,
2 questions are there. So
okay, 2 questions are there. We have NPTEL submission tomorrow. Then I think, so you can keep it as next Wednesday or next Friday, sir.
next Friday.
Yeah, not this Friday, next Friday.
Okay, Thursday. Shall we make next Thursday?
Yeah, Thursday is also fine.
Okay, date. Kindly tell me date.
So the date is today. Today is 13th, so it should be 22nd.
22nd.
Yeah.
By the time we'll be finishing, or I think.
Okay.
Hmm.
Because we have first phase of the project, this thing also on 21st. So I think 1 year of gap.
What is that? Presentation is there?
Yeah, that synopsis we are supposed to submit for the guide. So
Acha, okay.
students may be busy in finding the base paper and subsidiary papers and all that. So I think.
Okay, okay. Fine. You have any project deadlines?
Yes, sir.
List is there with you.
Yes, sir. I have.
Can you send it to me so that I'll
Sure,
also
sure.
I'll keep it with me. And
Yes, sir.
please tell everyone to submit by next Thursday. Okay, date is 22nd. No,
Yes, sir.
22nd. By 22nd they have to submit. Okay, fine.
Okay.
Okay. They have to post the assignment on that our Google Drive. Same.
Yeah.
Okay. Okay. Fine. Thank you.